All right, I think we're going to get started. It looks like we have enough people in the queue and certainly more people, it looks like, maybe joining now. Thank you all for joining us. My name is Richard Garber, and welcome to what will be the first in a series of lunchtime lectures that we've curated this summer as part of AIA's Technology in Architectural Practice, or TAP committee. As I said, my name is Richard Garber. I'm a co-chair here along with Matt Poltorek of the TAP committee, and we've been working together to bring to you what we hope will be a technologically focused yet wide-ranging group of curated lectures this summer. Today, we're going to hear from John Cerone, who's a principal at Shop Architects, and I'll introduce him in a second. John will be followed next week on June 25th, same time, by my colleague Laia Mogales Soldevilla with a lecture titled Reviving Matter for Regenerative Architecture at Duomo Lab. She is a materials scientist and a colleague of mine at the University of Pennsylvania, and she'll be sharing some of her very interesting work next week. We'll skip for the holiday, and on July 9th, we'll hear from Carl Daubman. Carl's a colleague and dean of the School of Architecture at the Lawrence Technological University in Detroit. He and his colleague, Sarah Kodarin, will be presenting a lecture called Practice in the Age of Intelligent Machines. That's a riff on Manuel de Landa's book, which he'll touch on artificial intelligence and its use in the service of design. I know that use of AI has been very important and of interest to members of AIA-NJ, and hopefully this lecture will start or allow for a useful conversation to continue. And then finally, on July 16th, same time, Winka Doubledom, who's just been named CEO and director of the Southern California Institute of Architecture in Los Angeles. She's a practicing architect in New York, her firm Architectonics, and she'll join me in conversation about technology and her term earth building by way of a new park and sporting facility she's recently completed in China for the 2025 Asian Games. Of interest, all of these lectures should be HSW credited, the elusive HSW credits, and so hopefully that's a little bit more incentive for you to join us for what I think is a really great cross-section of goings-on in architectural technology and architectural practice. With that, an old friend and colleague, John Cerone, has agreed to kick this off. And welcome, John. John is a principal at Shop Architects, where he directs dedicated initiatives for model-based delivery and offsite manufacturing. So super topical work. He is internationally recognized as an innovator in the exploration of future technologies for design and construction, and his work in design for manufacturing and assembly processes, CAD/CAM integration, and automation has defined the success of many shop projects, including the Barclays Center in Brooklyn, the Nassau Coliseum, and the Botswana Innovation Hub, which is in Africa. John was instrumental in the creation and launch of Assembly OSM, applying automotive and aerospace manufacturing processes to transform capabilities in the practice of architecture, engineering, and construction. And he leads both shop and assembly in transdisciplinary consortia that include key companies from the automotive, aerospace, and marine industries. John received a Master of Architecture from Columbia University in 2008 and a Bachelor of Architecture from Miami University. Please welcome him as he presents the lecture, Process Innovation and Industrialized Construction. Thanks, John.
Great. Thanks, Richard. You can hear me okay?
We can hear you just fine, and I'm going to stop my share.
Awesome. Well, thank you all for the opportunity to present this in this key series of what we believe, obviously technology and architecture in the AEC industry, incredibly important and relevant and timely. If you can see the screen, Great. And so there's a lot of content here. I think we're going to shoot to do it in 40, 45 minutes, so we'll have time for question and answer afterwards. So I'll just get moving. Again, thank you guys for the opportunity. Shop, we're an architecture firm based in downtown Manhattan, New York-based firm with a global reach now. This will not be a presentation on our design philosophy and projects. We don't specialize in a specific type of project. We're kind of all over the place from high-rise residential, mixed use, large commercial office arenas. We really focus we're generalists. But if you zoom in to all of our projects, the constant theme has been materiality, how we leverage technology and process, how we can leverage technology to execute, how we can use technology really to evolve the design into the execution process of the build. We're focused on built work. We are obviously theorists and a lot of philosophical thought of how, but really it's grounded in doing. And so our industry, if you sort of look at it, we've sort of been doing the same thing, or not a lot has changed. I would argue in terms of the role of an architect designer is to create three-dimensional constructs. Ideate, think of spaces that offer delight, and sort of these complex constructs really come down to the piece and part. So it's always been sort of around the conceptual thought of design of space, but really it gets down to how you can execute that. The ability to communicate the instructions or what goes inside the building. And Shop has always looked towards industry at this. From the DNA of the firm has always looked at automotive and aerospace on the idea of a part, a subassembly, its relationship to the whole of the design. And the instructions, when you're building models, you never read anything. You sort of, piece 28 snaps into piece 27. So this idea of the design, the understanding of the bill of materials, and the instructions for how to put something together. And we believe that you can manufacture capital A architecture if you understand materiality, the process involved, and if we get involved in the production and relate design into a constituent part and process of making it, the communication tools can change. And again, at scale, the philosophy of the firm, almost, I would argue naively in the beginning, is that you can design and manufacture capital A architecture. The initial, pavilions were all a sort of exercise in this, sort of design complexity, materiality systems, but really the instructions. We're not talking plan, section, elevation anymore. When you're creating pieces for assembly, the modes of communication can change. So that's sort of the DNA of the firm and the kind of working thesis. And, I think it's important that in 2015-16, there was that big McKinsey report that basically identified the decline in productivity in the AEC industry compared to advanced manufacturing, and understanding sort of what we were focused on as a company, and our sort of philosophy. We weren't surprised by it. I think what we're excited for is that if we can kind of realign philosophically, there's an opportunity to not just incrementally get better and sort of take derivative efficiencies from other industry, but we actually have an opportunity as an industry to leap into sort of phase shift into new ways of working, a more industrial minded way of working, and that we can be afforded the advantages and efficiencies and, hopefully margins of other industries. So again, we're downtown New York. If you come to the office, the first thing you'll notice are there are model planes and cars and boats everywhere. And there's a form function narrative to that. They're all planes, they all fly, but they have a different performance envelope based on the the function that they serve. But the other narrative, and the one that's sort of more focused on this presentation, is the technology. The firm was founded while both computers were hitting design studio floors, and the Nova specials around how Boeing was producing the 777, the CAD/CAM revolution of the mid-90s. So this idea that the computer is a way to design, simulate, fabricate products really sort of informed how we work. And I'll start moving quicker through this, but it's really sort of foundational. There is a conventional set of industry tools that we all use in the language BIM. I think we're all understand modeling, but we sort of learned early that to work at a capacity of other industry at that level of both detail and the amount of data, that you really we learned to expand outside of what we obviously fluent in the traditional AEC kit or the conventional kit, but really expanding outside of that into other tools. So pavilions, 2000 was the sort of launch of Shop, this Dunescape project, PS1, and this was, there's a whole design theory around this and ergonomics, but really this is a form made in the computer. And then the important part is that the instructions, how to build it. And this was done by at 1-to-1 scale plotter paper, plot outs of the lines, the center lines of the cedar sticks. So this is a building material. It's 2x2 cedar sticks and screws. So the printout is the only mode of communication. That's the construction documents. Lay the sticks out, screw them, and then sort of extrude this thing along a path. We hadn't done a pavilion since 2000. And in 2016, we actually did two simultaneously, one for Design Miami art festival, and then one for a festival in Milan. And in those, we're now have found that these are great ways of testing, one, collaborations between partners, but new technologies. So on the left in Miami, we're focused on additive manufacturing, 3D printing. Can we do something in one part, the fewest amount of pieces, part count as possible? And then in Milan, we are using terracotta. And what can you do with terracotta? You can extrude it and cut it. So traditional materials, many piece, multi-piece. Both of these, like pavilions, are a great way to, 3-month exercise of design done. It's important that they're on time, but it's life safety isn't as much of a concern. So you're able to test processes quickly. On the left, again, large scale additive manufacturing. On the right, traditional processes of compound mitering pieces of terracotta extrusions. At the end of the day, pieces are, it's a part sitting with a label. And so this becomes a logistics exercise. And, how do we use the model to, one, sort of informally just map out where things will go and how they'll be assembled, and more formal documentation for assembly if another crew has to install that. But at the end of the day, it's how you put these pieces together. So these exercises are quick in design, but also material process and then sort of logistics. And what we do with these, if we take the Attorney, for example, we're dealing with a German terracotta fabricator who's looked at the same fabrication ticket. They want their information a certain way. We're building everything in sort of live digital models. And so the exercise here isn't challenge the process. Don't automate the machines that are cutting this, but can we use the model to automate the production of exactly the same information that they would be used to seeing? So, sort of take out the complexity, don't sort of meet people where they are in terms of production, and automate that. So these processes, these sort of quick exercises and, formal, and then process study, we write a lot of tools while we're doing this because, obviously computer models, this is Rhino in this case, don't like to handle a lot of things that make a lot of triangles. So complexity, how do you simplify geometry, write tools that can manage that more easily, and then upscale the process. And when we build tools that help us in a design process, we keep those, we package them. Sometimes in this case, Sasquatch is a component, a Grasshopper component that we released a plugin. When we try to heat process, package it, and reuse that at larger scale. So these pavilions are great ways to test things and then scale up. Barclays is our largest, at the time, certainly our largest prototype in process. From concept, our first sort of sketch to opening day was a 3-year exercise. So a project of this scale, in complexity, downtown Brooklyn, no laydown area over a lot of subway lines. It's a wicked problem in that sense. So hugely constrained in terms of the set things. There's a budget. There's a time it has to open. So you're working in a way, that you're solving problems at a consistent clip. So this idea of when we're designing these kind of lightweight traces in, 3-dimensional traces, the idea of defining zones to work on, a sort of taxonomy. We move through a lot of iterations in terms of, testing things for aesthetics, for material quantity, for code, light air access. There's a lot of manipulation in real time, and every one of those processes reporting at a kind of granular, or I'm sorry, at a sort of global level of area. We're tying it back to quantities, costs. But those same models, those lightweight traces, we're building ways of automating the application of more detail. So we call this a sort of vertical grid. And the project, formal side of the project really is lightweight inputs. And then, this is actually right when Grasshopper was coming out. So we're certainly looking at Grasshopper. Parametric modeling isn't new now, but we sort of had an instinct that we needed to use a more robust modeling tool because we knew that the scale of information was going to increase exponentially quickly. So lightweight models for parametric control, but also the ability to build sort of templates, to start defining systems that would then fill out the eventual solution. So this idea of going from lightweight, keeping globally the design flexible, dealing with lightweight geometry for design input, and then building templates that would turn surfaces into sheet metal parts and assembled products quickly. That's sort of what we were solving for in real time. And those design models evolved. There wasn't a sort of concept design, schematic, design development model, production model. It was one model that evolved into the means of manufacturing. So these mega panels, 10 foot wide by up to 45 foot tall, 950 different panels. So it's probably around the 500,000 part count for the whole enclosure system. This is an offsite manufactured product designed for manufacturing and assembly. We weren't calling this at the time in 2010, but it was, these were produced in a factory, basically shipped one truck at a time and installed on the building. At every design move, we're sort of rationalizing the piece part count. It was sort of a humbling experience dealing with the manufacturer. The long lead item needed to order 600 tons of steel. What sheet size should we order? And so we have all the sort of unfolded solutions. Even before, you can see there's no detail in the connection. We didn't know how we'd attach them. But that kind of question, how do we answer that? We take the design as it stands, and we can nest all the pieces, parts, and sort of look for efficiencies or waste. In this case, finding where there'd be huge, offcuts, and then, working with them to say, okay, if we were to pick one sheet size, we can adjust our design models to now fill that out. So this is a sort of in real time, taking on a fabrication constraint and then adapting design to make that a more efficient solution. There's over 12,000 of these weathered steel panels. We knew that they were going through the water jet. It's important to understand the constraints of who you're working with. This is all about people. I think if there's anything to sort of take away from this, technology is not the barrier. It's sort of communications and trust with both the technological solutions, but also the people involved. So, there's no dimensions on these panels, which was a prerequisite. But we're saying we're going direct to water jet. We can actually provide you, what we know how to do is automate the unfolded solution and nested water jet files. It's actually at that time, we didn't know how to automate dimension strings. So is that something we can shortcut, run some tests on panels? Does it work? And then you're able to kind of negotiate that solution. So 12,000 panels that were done in 4 batches. So it really runs of 3,000 panels, but we're moving outside of sort of construction documents and shop drawings. These are fab tickets of the pieces parts. You then see how it's being processed. You see people walking through a factory floor with clipboards, checking off, which pieces have been processed. We were tracking all of this in a database at this point. We sort of outgrew the Excel sheet, moved this into a database, and we could give you an iPhone interface. You guys can scan these. We'll give you barcodes, and we can now in real time host a model online, and everyone can see in real time the status and progress. So this, we're sort of looking at this kind of data visualization in 2010 and 11 for production, just to kind of, it saved us from having to produce reports, but everyone sort of understanding where things are in real time. So Barclays really sort of set, when the dust settled from that 3-year sprint, because we hadn't set out knowing we would build tools to solve this. Everything was sort of a reaction to a challenge that we were facing that week or month. So when the dust settled from that, we really felt we had a roadmap. We were working on some projects, and this is in Kanza, in Kenya. And of course, these 3D models that we know we can use for environmental studies. We started pre-rigging these to be the inputs. We don't know if who's going to be supplying this. We don't know if we'll have a relationship with the fabricator, but the way that we're designing, we know that we could start working with engineers, on the team to start building these out to create the cut files. Again, not with a specific vendor in mind, but knowing that we could calibrate these to the requirements of a system that was told to us. And we just started building this kind of repertoire of even sort of for other vendors who working for other architects to start building this way of modeling and manufacturing. In the heels of Barclays, the same team, the same ownership development team and contractor, they had purchased the Nassau Coliseum, which wanted to update it quickly. And so we took that previous one and turned it into this quickly. It really was a rapid exercise in terms of, now what are the requirements, 45-foot span between these piers, what's the lightest weight intervention that we can do. It was a design bid build. Facade contractors came and proposed methods. One came with this incredible idea for a space frame, 2-point connection. So breaking down these systems. But while we were designing this, we already know this was a very informal in the sense of deliverables. Everything kind of being done through the model. While we're designing this as a sort of folded, articulated aluminum panel, we already know we need the unfolded cut file. So the design model had all of that embedded in it. So we're able to sort of move through kind of concepts to prototypes quickly. All the design decisions really were made through model review. We know to digitize the site whenever especially if we're going to anything that's pre-existing, laser scanning, so that we're kind of fitting a bespoke suit to that. But working at that capacity, this is actually the opposite challenge of a Barclays Center. There's tons of laydown area. So all the pieces, the space frames, and the aluminum fins were all manufactured aluminum in Canada. I think the space frames outside of Chicago. But everything showed up in crates, but manufactured. So it really was assembled in front of its constituent bay. There's 32 bays. So this project was done in 32 picks. So it sort of sat, we had it painted black, and it sat like that for months, and maybe people thought there wasn't progress happening. And then once these were assembled, it went up very quickly. So that kind of quick transformation of a project. So again, we know it's repeatable. In that same sort of era, we're looking at a project in Gaborone, Botswana, a fabricator in Cape Town, South Africa. And again, this roadmap for digital process. We know how to set these projects up digitally. We've since upgraded to more cloud-based systems where we're looking at portfolio of projects. So across projects, looking at systems of ways of working, but we can move across projects to project down to a scope or zone, down to an individual rain screen system of that project. In this case, there's 3,000 rain screens, like 1,700 of them ish are different, but down to the individual part and piece. So this ability to move through these scales of a project fluidly, the way that we do this is this wireframe process. This is sort of consistent on all of these ideas, that we create a lightweight, agile skeleton that describes the form. And while we're working with engineering and manufacturers, we can take that information and start hosting systems on top of that wireframe. And we can build in all of the documentation or CNC code that's needed, and we can package that into a template. So these 8 templates would account for 500 slightly different units. And while you're doing that in real time, all that information is available through web portals where you can pull information that you need, as opposed to kind of trying to document everything. In this case, the manufacturer in Cape Town had never done a 3-dimensional CAD project before, but they had these incredible German CNC machines, these Illumitex, that we knew you could load in solid models, and they would take care of all the notching, drilling, marking. So the majority of the pieces were just right from our solid models. The panels are water jet, so that was a process we already knew. But the assembly drawings, the documentation was actually much lighter lift than Barclays, in that it's just these kind of IKEA style approach. These were fabricated, sub-assembled into their frames. You can see the 3 frames, flat packed, and then shipped to the parking structure of the project, which became a pop-up assembly plant. So, not high tech. We know there'd be sort of indifferently skilled labor, not a lot of heavy equipment to lift these, so they were sized so that 2 people could manipulate these. But again, sort of a low tech assembly approach. Again, we did most of this work, like almost all of the facade work, from New York, from our office here. So the idea of digitization, of making sure that these models are really sort of bespoke to the conditions. We know there's going to be tolerance, certain tolerance issues out there, so that we can adjust the deliverable according to that. And again, that these kinds of processes where we are increasingly convinced that you can achieve capital A sort of high tolerance architecture through these industrialized manufacturing, technology forward approaches. In this case, fraction of the budget of a Barclays Center. And so it's portable. And again, this is a process we're refining over, a decade on enclosure systems. The facades of the building, which tend to be the most industrialized process. But our intent and realization is that this idea of a wireframe and a system is scaleless, right? So we could start looking at this towards master plans, especially since the conversation around, we're excited that developers and contractors are starting to and just globally take offsite manufacturing. I call it industrialized construction, but modern methods of construction. There's a lot of new terms for this, but the idea that there are new techniques for pre-assembling. We started looking at this towards master plans that we were proposing, that the same idea, the same way we could break down a building into its parts, we could take a master plan, a district, down to a block, down to a building, down to its piece and part. So this powers of 10 ability to move. If we start considering the city grid or infrastructure as a wireframe, as a agile wireframe, this idea that concept masses have obviously different programmatic requirements, might have different performance requirements in terms of structural systems. But can we look at a building as an input, the mass of a building, and if you have a catalog of steel, concrete, or in this case mass timber components, can we automate the production of that, or the deployment of it quickly. And it's not to say that we have to pick curtain wall anchors at master planning, but this idea that we can use automation to evaluate decisions faster with more confidence in the information, that is something as an industry we should be more precise and accountable. And that you have, at the different scales, live dashboards where people can pull information they need. We did have, after Barclays, we did design, at the time, I think it's the largest modular building in the world. I think it still is in North America. It's 32-story, fully volumetric. At the end of the day, the product is very successful. I think it's fully leased. There's a huge affordable component to it. The building managers love it. But the process, everyone was sort of looking at it to be faster, and there was a lot. Mostly the takeaway is that the way that this was executed was modular under a roof, or I'm sorry, it was more construction under a roof. That's how the modular component was treated. So, I think we understood that, the way buildings happen, all the material shows up, it's cut, done to in situ. It's disruptive, obviously, construction, especially in urban in urban centers, very messy, distracting. The way that this modular was executed was a similar mentality. It was really construction under a roof. And we feel that there's an opportunity to, again, leverage technology to manage a more sophisticated system of suppliers, tiered suppliers. And so this idea of a industrialized manufacturing approach towards building, we sort of incubated, sort of theorized and incubated and launched Assembly OSM, which was dedicated towards high-rise residential modular design and manufacturing in urban centers. And it really is just kind of following what we had been doing on enclosures. So of course, a template for the enclosure system, but build flexible templates for every system: structure, MEP, bathrooms, kitchens, and through that, creating these flexible templates. It's not easy. Obviously, there's a lot that goes into it, but it's also not indeterminate. We can build flexible systems that then aggregate into a bespoke building. So what we were doing on enclosures was really kind of what aerospace, automotive were doing in the 90s, which was this, the digital twin was the CAD CAM revolution. If you look at where other industries have evolved to, which is much more sophisticated supply chain, global supply chains, distributing parts and pieces to a network of builder, or in this case, manufacturers, and reconstituting projects. There's a lot of reasons for it. But that, that level of sophistication, we're now, same idea. We can start building tools that manage the pieces, parts of the component, much more sophisticated understanding of taking the manufacturing systems, simulating those digitally, but more importantly, or as important, testing those physically. So this is a one-bedroom prototype with a real supply chain. So bathrooms from South Dakota, floor cassettes from Michigan, kitchens, Arkansas, MEP systems from Massachusetts. But can we send information out to suppliers, have it come back and assemble a project? So this is a sort of market rate New York apartment assembled in a factory. And as that scales, you move to a 3-story brownstone or townhouse in near Barclays, actually, in downtown Brooklyn. The most robust townhouse that's ever been built because it's the full structural system. We wanted to test it on a real project. But moving the system through assembly facility and really with the target of stacking in a day. So these components, it's a landmark building, so the brick had to be applied later. But this is fully enclosed, so the building stacks. We don't close a lane. And that idea that, and the idea is being that it doesn't look or feel modular. It's a building like others there, and with sort of nice interiors. And doing all this to test, get the reps in, because with a 8 mod structure, you're able to kind of remediate any certain issues testing the supply chain. You can kind of brute force it. On a large project, like a 15-story project, which would be around 130 mods, you really have to calibrate the systems and make sure that you can't brute force that. So building the tools to be responsive. The byproduct of this is that you just really have a great understanding of what's inside the building. The visualization, the idea that architects are removed from the build and then therefore the supply chain, ideas of the carbon footprint, or in this case, sort of forced labor is a major issue in our industry, that we start having visualization and impact, input on what what constitutes our buildings. I think that we can work at this. The more industrialized we become, the more insight we have on this kind of information. Also, the opportunity to experiment. Actually Oak Ridge National Laboratory, who we worked with on the Miami project in 2016, approached us again and said, they're working with University of Maine to do a study on large-scale additive manufacturing, 3D printing, of bio-based materials in the construction industry. Is there a viable market for that commercially? And so we don't know, they didn't know, were they thinking we would 3D print a house or something like that? And we're like, it's not going to be necessarily as sexy, but we're already sort of so industrial minded right now, thinking about components of our buildings. Let's just take one system, a floor cassette, which is, multi-part steel system. You have to do a lot of engineering to make it not feel light and tinny. From what we had remembered from Miami, the 3D print of a bio-based material feels like concrete. So all we're really doing is solid stating, something that's a multi-piece. You can print so that you can accommodate for the systems inside. We actually originally proposed we could even 3D print the systems that would be integral. But we started very simply and, with this, have the structural performance. And, the initial tests were compelling for sure. And then, with the theory that we could start swapping assemblies in our buildings with these sort of solid state prints. And from there, we received a NYSERDA grant to continue those tests. But what's interesting is over the course of a year of these, running these tests, the printing, the ability, the tolerance, the printers at University of Maine, the equipment, the throughput is just getting much more accurate, much higher tolerance. So the speed and amount at which you're doing this, you're sort of seeing in real time a viable approach. Building code is going to be the biggest issue, obviously, for bio-based in the floor. So you can quickly pivot these studies to other systems of the building that are less have less strict requirements. Although this same technique, you can print ceramic and concrete too. So the concepts are valid. And when you're in this sort of 3D printing space, this additive manufacturing, the idea of optimization, that same floor cassette, if you run it through an optimizer, that we can really get down to putting material exactly where it needs to go and create these, at 10% of that material that was already efficient, you can create really high performance systems through that. And again, the week that we had actually run that experiment, on the cover was, the SpaceX rockets. And really, again, this is just a reminder, we're still just kind of along the same path as other industry. This idea that through 3D printing, the idea of integrating systems and just making much more simple, performative, efficient builds, that's the path that we're on. And I move through this now just quickly, in that this has gotten us into other sort of fringe projects, like infrastructure projects. Someone came to us with a solar carport. We didn't design it. It was a 2D CAD project, but interested in maybe doing more variation on deployments, a better understanding of the manufacturing process, designing new lines of it. So, this idea that this wireframe, we could take contextual inputs, soil or sun, wind speed, and build a wireframe that could accommodate that, host systems on top of that, whether that's their design or new designs, and at the same time understand how that flows through a manufacturing process and ultimately a packaging and logistics. We have a 360 room in our office, so this idea of kind of like visualizing and simulating things in real time is helpful. And again, so similarly, a FlexNode, a modular data center company startup, had come to us also with an idea of a prototype, and the idea being, can we move these pieces and parts through freight elevators of existing buildings? So structuring the model into its right size subassemblies, understanding who or what would be lifting these, how they're packaged. Again, this idea of a live wireframe. The idea that we can, build these things flexibly, that we don't have to lock into a dimension, and every time something changes, especially in the equipment around data center infrastructure is changing constantly. So this idea of a flexible system, and then communication with suppliers, whether it's having to create fabrication tickets, which come out of the drawings, or dealing with, more sophisticated suppliers and infrastructure that we can just hand the models to directly. We can go from this idea of designing a system into prototyping. We on the side, we have a small fabrication shop in Brooklyn where we can test other systems or sort of design layers, but understanding that also there'd be different types of systems for blast requirements, things like that. But like you can start experimenting with other buildups simultaneously, understanding the tools, simulating this, and then going from kind of design to prototyping in sort of days and weeks, as opposed to what would be these sort of weeks, months, years. And I'll quickly sort of wrap with, this feels like a shift in the conversation, but we see it very much a continuum. This idea, the way that we work right now is fractured, it's siloed. There are models, there are two-dimensional drawings. A lot of the stuff is happening in everyone's own sort of silo. This idea that, can we get behavior around a persistent model environment? We know collectively that a huge amount of engineering and data and detail goes into these projects, but we're collectively trained to open, whether it's Revit or Navisworks or CATIA or Inventor, we can open these tools. We're trained to do that, but no one else has access to it. So everyone has mobile devices. So we started producing this idea that we could provide access to the models more intuitively. And we were building, and it was originally for some, sort of museum installations, but we started building these kind of one-off tools with game engines, where you could access that information. A lot goes into that. You're optimizing the model to run on a mobile device. So there's kind of a data cleanliness that it forces you to do, which is a good thing. But this idea of understanding the built construct, the environment, the systems in it, that these start becoming, you have more access to insight on that. And that the mode of it, the idea that you could, especially if we become more industrialized, it's the BIM or the kind of digital twin isn't a checkbox or afterthought. It is the means of how you put it together, which means it is correct, which makes it a lot easier to create this digital underlay. But we were doing these one-offs and sort of building it to a scale where we realized we created an app, and really it's more of a kind of digital infrastructure that lets us take all of our projects and work that way. So we don't want to create a model for design and a model for rendering and a model for documentation. Can we have one model and hit endpoints, stream it into the documentation, stream it into mobile devices? So building tools that let us do that quickly. And then when you do this, focused more on what's more important than the kind of what it looks and feels like are these potential for data layers underneath that. So that this sort of becomes a building information visualization, BIV. We sort of joked, about BIM, whatever it is. The idea that we can paint by data becomes a really important, BI Essentials isn't anything new, but this idea of kind of spatializing it, integrating that into how we manage buildings or components of buildings up to facility management, campuses, that there's this ability to connect the built environment to its digital counterpart and understand the complexities or manage complexity and information more intuitively. And so this is sort of a weird study, this is the Atlassian headquarters we're building in Australia. But this model in our office, the idea that this is an AR overlay that will manipulate the lights and controls of the model. It's sort of a fun, novel thing that we can run in real time. But if understanding that the IoT and the way smart buildings, that the idea of the Internet of Things and internet and connectivity, this idea that we can interface with our built environments and our buildings, and that we can start to model in a way that is kind of pre-configured or calibrated to adapt to new methods of physical and digital infrastructure. Again, the industrialized approach, I think, the way that we operate is going to change dramatically in the coming years, and there's an opportunity to really tightly integrate the design and operation of space. And I know that might be a sort of weird way to end that, but it is all part of that same continuum. So trying to think holistically around process and design and execution and operation. So I'll end there. Thank you. I don't know what happens next.
That's great, John. Thank you very much. That was awesome. We do have a series of questions.
Uh-oh.
And so let's go through them, and we can spend about 10 minutes. There's 3 that I think may actually take 10 minutes, but if others have questions about what you just saw, please do submit. So the first is by Daniel Wyckoff, who sent one question earlier that I attempted to answer, and then he wrote back. So he first wrote, will 2D representation ever become unnecessary? And he followed up with that with a comment. We spend so much time investing in modeling in 3D only to translate everything into 2D.
I cannot agree and emphasize that enough, Daniel. It's a controversial thing to say. Like I do believe contractually, we are not set up to move away from that. I think it'll be incremental. It'll be with Department of Buildings accepting 3D models. It will be with partnerships and clients. We have had some very successful contractual language with some of our tech clients where this idea of model-based delivery, it doesn't mean model for manufacturing. It's sort of, let's ease into it. Where can we sort of informalize the schematic and maybe DD stages? The short answer to that is I think yes. I don't think the future we rely on drawings. I think we can pull two-dimensional orthographic views of things. We can pull the information we need. It's a spatial discipline. The environment outside of spatial, it's a 3-dimensional exercise. I think defining things in 3D and embedding information in a model will be the future of this. So I can't agree more. The amount of effort that it takes to use a model, abstract it into 2 dimensions, and then for certain disciplines to reconstruct it at best or redraw it in other areas, it's just that's incredibly inefficient. And there's just inevitably we're going to move to more industrialized processes, and industries moving towards more model-based processes, especially for logistics and simulation. So I think, yes, we will move to 3D. I don't know how long that
So
is,
if
but
I can add to that, John, as a
yeah.
point of discussion. So, it's funny because on a practical level, I think state of New Jersey is if not the only, one of the only states that still require hard copy tender drawings to have raised seals. And we just had an intern here probably sign, literally seal,
Mm,
500 sheets yesterday or something like that.
yeah.
And so I do think that you said DOB, like, I do think that at the municipality and at the state level, changes, will need to be enacted. But the other thing that I thought of, as you were speaking is wireframes are 2D constructs. Now they're not 2D constructs in the same way that, 2D traditional architectural drawings are, but I do like this idea that representation in terms of two-dimensionality kind of starts with a wireframe that can get built upon in the modeling process, right? So
Yeah.
there might be something there.
It's a way to just, it's like a three-dimensional, it's the way to describe a three-dimensional composition in really lightweight, like points or lines
Yeah,
or surfaces that then,
yeah,
yes, can host
yeah,
systems.
yeah. All right, to keep moving, we
Yeah.
have a question from Paul Adams, and I'm just doing these in the order they came
Hmm.
in, by the way. Um, can you define project forced labor in this context?
Yeah, I mean, I think in the supply chain, how materials are sourced and produced, I just think, particularly overseas, we don't typically see it, but there's a huge amount of forced labor, like and not uh, you know, yeah, it's a sort of modern slave labor, and it's really it's prevalent in a lot of areas of the world, and I think there are people that are doing research, and um, I don't know if I'm allowed to mention the just because of the AIA and all that. I don't know what companies we're allowed to name, but there are companies that are focused on creating indexes that define where inadequate labor practices are happening and the likelihood of forced labor or sort of bad conditioned uh, uh, practices happening at what part of the supply chain. It's not just architecture. Right? It's anywhere where mining of ore in along the lines of how the building products that come into the buildings or phones that are the likelihood that there are really bad humane practices happening in the process of that. So it's in this case it's another metric in terms of like the way like carbon the way we source and pick materials based on carbon footprint. It's a similar ability to kind of understand the material, the quantity, and the sort of resultant. Um,
I think the flip
yeah,
side of that is, Botswana, where there was really this kind of goal of knowledge
yeah,
transfer
yeah.
in terms of in terms of enabling a local community with the kinds of technologies that you talked about, which is
I think I
yeah.
think that's a huge opportunity just in general. I mean, we know that the construction labor force is declining. We know that there's this idea and desire to bring more ability to manufacture, to the states. And this, what is the future of us? I don't. It's not going to be the factory lines of the way that they had been historically, but there's a big enabling side of this of um, designing systems that can be assembled, sub-assembled offsite in much more comfortable um, facilities, and that the sort of mechanically fastened process. There's ability to engage more in differently skilled labor for sure.
Great. I'm going to piggyback two questions on top of one another now. The
Mhm.
first one is by Lotus Grenier. Did I say that right? And I'm going to follow up with one from Johann Kettler. Lotus, you identified that the people involved in communication are key components to the success of your projects. How do you initially vet if a partner will have the communication skills needed for the duration of a project? And before you answer that, more of an internal question about,
Right.
workflow. What's the composition of shop staff between architects, engineers, software specialists, skilled labor to pull these projects off? Do all the architects use CATIA? So maybe
Yeah.
that's a kind of internal and external question
Yeah.
for you.
Look, I don't think it's a defined science, or like there's not a specific recipe in the sense it's what do you how do you vet the people conversation. I mean, you meet them, you understand there's still so much of this like kind of soft skills or just understanding people appetite for innovation, how knowing when to sort of pick and what to sort of fight to automate or not fight to automate, what's going to be the biggest return on efficiency. Like it's just feeling people out. Obviously you don't want to it's good to work with people that you enjoy. I mean, designing construction it's tough, and obviously there's moments that are more kind of caustic or heads down. But at the end of the day, you're working. I think you can tell when you're working with people that are like you get the temperament of people, and if you've got we've been fortunate to work with good groups and collaborators even through tough times where you have to be reasonable. There's a sort of give and take in what you're willing to test and try within those bounds. So it's not a hard, pass these three tests. I know there are companies that are trying to evaluate like a maturity of supply chain readiness. I think the more that this industrialized process is defined, there will probably be more objective metrics that kind of like rank people. But I feel like if you have the right temperament and sort of understand what to push and where any one can be like a great collaboration partner. And internally, it's similar. We don't, to that point, not everyone uses CATIA at all by any means. We have the philosophy the philosophy of the firm does attract younger sort of tech-minded people. So we in general have a good fluency in the upcoming and emerging tools, which we curate. We listen. An important part of the firm is to sort of listen to young staff when they propose, let them try certain things and then curate it so we can tell if something's we can quickly tell if something's going down a rabbit hole, but you can sort of direct this energy into applied technology. But I would say, a handful. I mean, we probably we're around 130 people, maybe 10 people know CATIA and maybe even slightly less use it on a day-to-day basis. But you can distribute this through the way we staff our teams to sort of mix and match that. And also we've come up with one of the reasons we're writing some of these tools for data infrastructure. We have a very small software development team. I mean, really, it's three people that also are sort of applied on projects. But we're trying to develop a pipeline that lets the way designers work, which is in 3D. We use Rhino. I mean, that's our authorship tool. To use that information, it can be very compatible with CATIA, for example. So can we think of how we're modeling and designing in a way that will lend itself well downstream to report quantities or roll up into components and things like that. So it's a little, what's the jujitsu or judo where you use the energy that's already like we're just trying to be smart about how we use that energy and move it towards a more industrialized philosophy. That answers the question.
Great. And then we'll do two more. Christina, we'll do two more. So we'll go for another couple of minutes here. But along the lines of supply chain, James Blanchard asks, so this is a kind of follow-up. How are you able to provide a pipeline for information and analytics when working on international projects? Does your team track what may otherwise be impossible to track or become experts when your team is based in the US?
That's a great question. And I would, so assembly, which is running around the more industrialized build, has direct access to supply chains. And, for there, you definitely get usually from other industry, supply chain expert, that runs, you keep track of all the data for sure. And there are robust ways between, ERP systems and things to manage that. I'm a, I'm a sort of more generalist in the sense that what we're trying to do is track data. Like we know enough now that if we're putting things, even if it's sort of unstructured, that I do believe is a promise of AI in terms of structuring and analyzing loose data. So we're in a phase right now at Shop that we're creating tools that can analyze all of our projects, whether they're in Rhino or Revit, CATIA, and can we centralize that data into a way that we're now creating a schema that we can start making sense, because we also have access to our labor hours and profitability of projects. So we are trying to aggregate data and use it very eyes wide open to look to structure it and look for insights, and then set up the way that we work to more align that there's just a data. When we're authoring something, we're getting quantities, we're getting hopefully, I mean, the thing we haven't had access to is the operations, how buildings are performing, which is unfortunately how, like, usually we don't have, as architects, we don't have access to that data. We're hoping with some relationships with clients that are larger portfolio holders to start having access so that we can understand how our buildings are operating. So I don't know if that was more supply chain data, but I would say all that, yeah.
That's good.
It's harder on the international projects.
Let's do two more. Ruminate on this one for 2 minutes, John, and then then we're out of time. And this is a simple question, but I'm going to expand it a little bit. So the question is from Robin Mercier K. Do you integrate your city scale work with Esri tools? Now, before you answer that, I just want to actually promote this as a question, because theoretically, right? If you are designing buildings within these platforms, and these buildings are constructed and out in the world, and the building next door is done so, and the building next door is done so, you can start combining these things and doing kind of like almost post-occupancy testing in terms of their performance, right? So I do think that there's this kind of interesting idea of clustering data at the scale of the city to begin understanding how these intentions are not only working locally on a site, like in a building, but also how they may be contributing to the overall fitness of a community, which is a very interesting kind of concept for me. Yeah.
We are not working directly with Esri. We know we need to. We know this, like, to this point, everything, the idea of geospatial location, we're doing it to index the projects, to start playing with ideas of tiling and Esri and cesium, the indexing of space and sort of registration of where things are located. That's going to become increasingly important, and we're doing that within buildings in terms of spaces. So if that's like we're doing some work in collaboration with like Cisco, for example, that are more involved in IoT connectivity operations. So the idea of a spatial location, incredibly important. Esri is a leader in that. We've simulated in other tools that are doing a similar thing. It's of critical importance that everything is kind of the ways that we're registering it. So I'm just we identified that, like, I say that we don't have access to how our buildings directly to the data of how our buildings are performing. But Google Earth, as an example, or Yelp or whatever it was, is a live data source of how people are responding to the built environment. So it is there's bots aside, whatever. But like in general, there's pretty honest feedback of how places are operating. People are happy to contribute and provide feedback if you give them access or platform to do that. So this idea that geospatially there is real-time feedback of the built environment, potentially of what requirements people would like to see in a pre-proposal. There's a huge amount of opportunity in federating all of that. And Esri is probably the biggest player in there. So only just because we've been focusing on the things that we've been doing, where Esri is sitting here, we know it is the big player. And when we feel like we have sort of a more kind of ready to scale and globally engage that, then those conversations will happen.
Wonderful. So with that, John, thank you very much, and
Thank you.
huge applause, and you know, I'm going to raise my hand and do that kind of stuff, the clapping or whatever it is. So thank you for for spending the hour with us. Really great content. Christina, thank you for all your help, and thank you everyone that tuned in, and hopefully you will tune in next Wednesday as well. Awesome. Have a great day, everyone. John, thank you.
all.
I'll give you a buzz. Okay, thanks. Ciao.
Just